This video is on Unit 3, Chapter 7, Rational Exponents and Radical Equations, Lesson number 3 on solving radical equations. So the steps are here for solving radical equations. Number 1 says to isolate the radical on one side of the equation. Secondly, raise each side of the equation to the power of the index to eliminate the radical sign. Thirdly, solve the remaining equation. And then fourth, check for extraneous solutions. So I want to talk for just a second about step number 2. It says raise each side of the equation to the power of the index to eliminate the radical. And that's because, let's say we've got a cube root. When we cube a cube root, those two steps are opposites of each other and they cancel each other out. Same thing would follow if I had a fourth root. If it's a fourth root, then we're going to raise each side to the fourth power. Again, so that eliminates that radical sign. So let's look at example number 1. Example number 1 says the square root of x plus 5 is equal to 12. And the directions are going to tell us to solve each equation and then be sure to check for extraneous solutions. So the last step, check for extraneous solutions, is also an important step to make sure that you're doing, because what we can do in the process of raising both sides of an equation to an even power, we can create solutions that didn't exist in the beginning. So step number 1 says to isolate the radical on one side of the equation, which means that in number 1, I need to get that square root of x by itself. I've got to get rid of that plus 5. So I'm going to minus the 5 from the left and the right side of the equation. And now it says the square root of x is equal to 7 because 12 minus 5 is 7. The understood index here is a 2. So now we're going to raise both sides to the second power. And we get x equals 49. And again, the reason why it's an x is because the square root on the x and the square cancel each other out, leaving you with just that x. So the next step, the last step, I should say, is to check your answer. So we're going to go back to the original equation and plug in our 49. The square root of 49 plus 5 is supposed to be equal to 12, and we're just checking that. So the square root of 49 is 7 plus 5 is indeed 12. 12 is equal to 12. That checks out, which means x equals 49 is my solution. So let's look at example number 2. It says 3 minus the fourth root of m equals 0. So to isolate this radical, we're going to subtract the 3. Notice there's a negative or a minus sign in front of this radical. Don't lose it, because to isolate that, we're going to have to divide both sides by the negative 1. So now it says the fourth root of m is equal to 3. And then the index is 4. So we're going to raise both sides to the fourth power. And that's going to eliminate that radical, giving me just m equals. And then 3 to the fourth power, 3 raised to the fourth power is 81. So m equals 81. And again, we've got to check that. So 3 minus the fourth root of 81 is supposed to be equal to 0. So 3 minus, I'm going to stick this in the calculator. 3 minus, go to math, select number 5, and we need a 4 here, not a 3. You may have to make sure that that's the correct index. And we got 81 for our solution. Again, this is supposed to be equal to 0, and it is. So that checks out. M does equal 81. All right, let's jump down to number 4. The square root of 6w minus 5 plus 10 is equal to 3. So isolating this radical, we're going to get rid of the 10. It's a positive 10, so we're going to subtract 10. And we get the square root of 6w minus 5 is equal to 3 minus 10 is negative 7. Now what we want to do is get rid of the radical. Again, the understood index here is at 2, so I'm going to square both sides. And again, the square gets rid of the square root. So I just have 6w minus 5 is equal to negative 7 squared is a positive 49. Then we're going to add the 5. And we get 54 and divide by the 6. 54 divided by 6 is 9. But now we're going to plug this back in and check it. So the square root of 6 times 9 minus 5 and then plus 10 is supposed to be equal to 3. So again, I'm just going to go to my calculator and put in that left side. The square root of 6 times 9 minus 5. I've got to come outside the radical with the plus 10. Again, this is supposed to be equal to 3. And it says it's equal to 17. So this does not check out. This is not equal. So W cannot equal 9, which means there is no solution to number 4. Nothing works. So that's precisely why you have to check your solutions. You have to check your solutions. Let's look at number 5 next. So number 5 says negative 36 is equal to negative 9 times c minus 12 to the 1/2 power. So thinking back to lesson number 2, anytime you see an exponent that is a fraction, like that 1/2, that means the square root. Now, if you need to rewrite that, by all means, you can rewrite it. I don't need to, and I would prefer that you didn't. But the steps are the same regardless. We've got to get this thing by itself because technically that is a radical. It's written in a different form, but it's technically a radical. So we've got to divide both sides by the negative 9. Negative 36 divided by negative 9 is positive 4 equals this c minus 12 to the 1/2 power. Now, I said to you in lesson number 2 that your index is the denominator. So the index on our radical is the denominator. So the denominator here is a 2, which means we're going to raise both sides to the 2nd power. And when you do that, these go away, leaving you with just the c minus 12. And then 4 squared is 16. Add the 12. And we get c is equal to 28. And we're going to check that. Negative 36 is supposed to be equal to negative 9 times c, which I got 28. Let me change that to a 28. Minus 12, and I don't need that. Put that parentheses in the wrong spot. To the 1/2 power. All right, so I'm going to put that right side in the calculator. Negative 9 times 28 minus 12 raised to the 1/2 power. And I get negative 36. So negative 36 equals negative 36 checks out. C does equal 28. Let's do number 7. Number 7 says the 4th root of 8k plus 12 minus 9 equals negative 11. Again, your first step must be to isolate the radical, which means I need to add 9 first. So 4th root of 8k plus 12 is equal to negative 11 plus 9 is a negative 2. And then from there, we're going to raise both sides to the 4th power because that's the index. And that gets rid of that radical on the left, leaving me with 8k plus 12 equals negative 2 to the 4th power. If you don't know what that is, we can certainly put this in the calculator. Negative 2 to the 4th power is 16. and then solve. Minus the 12. 16 minus 12 is 4. Divide by the 8. And we get k equals 1/2. And then we got to check. So going back, putting this in. To check. So 4th root. So I'm going to go to math, select number 5, put in my 4th root of 8 times 1/2. 8 times 1/2 plus 12. And then come out, say minus 9. Again, this is supposed to equal negative 11, and it doesn't. It equals negative 7. Negative 7 does not equal negative 11. So this does not work. K cannot equal 1/2. This one's also no solution. Let's jump over to number 9. Now, notice on number 9, we have radicals on both sides. Both radicals have the same index. This is probably the easiest one on the whole page. We're going to just go ahead and square both sides because there's no way to isolate. And that's what's going to be confusing. You've gotten into such a good habit now of isolating the radical, and we can't isolate the radical here. We have to just go ahead and square both sides. The radicals both go away. You have u minus 8 is equal to 43 minus 2u, and then solve. I'm going to add the 2u. And we get 1u plus 2u is 3u minus 8 equals 43. Then we're going to add the 8. 3u equals 43 plus 8 is 51. Divide by 3. 51 divided by 3 is 17. And then again, we have to go back and substitute that 17 back in both sides and make sure that the left side does equal the right side. So square root of 17 minus 8 is 3. Now the right side, square root of 43 minus 2 times 17 is also 3. So it does check out. U does equal 17. All right. Looking at number 11. Look at number 11. Again, we have radicals on both sides. There's no way to isolate that. So the one thing that I could do is divide both sides by 4. We could totally kind of simplify this just a little bit. It's still not going to be perfect. 12 divided by 4 is 3 times the square root of q. Now, here again, we still have radicals on both sides. The index here is a 2, so I'm going to raise both sides to the second power. Now, the left side is easy peasy. The radical just is eliminated by that exponent of 2. But when you look at the right side, here's where students are going to miss this. The q that's under the radical is going to come out as just a q. But what do we do with this 3? The 3 is inside the parentheses, and it's being told to square the 3. So you should get a 9q on the right side. Now I want to subtract the 3q. And we get 9 minus 3 is 6. Divide by 6. And you're going to get q equals 15 over 6 is 5 over 2. Reduces to 5 over 2. And then you'd have to substitute that back in. 4 times the square root of 3 times 5 over 2 plus 15 equals 12 times the square root of 5 over 2. And I'm going to show you this in the calculator because this one's going to be a little confusing. So we're going to go with the 4 times the square root of, we got 5 over 2. So 3 times 5 over 2 plus 15. And that's a hot mess. Now, as long as the right side is the exact same hot mess, we're good. So we're going to do 12 times the square root of 5 over 2. And we get the same mess, the 18.9736. So what that means is that that checks out and Q does equal the 5 over 2. All right, I'm going to jump on down now to number 13. And we have the square root of 8x is equal to x. The radical is already isolated. The index is a 2, so we're going to square both sides. And we get 8x is equal to x squared. 8x is equal to x squared. Now, we just created a quadratic. And that means we need a 0 on one side. Oops, that should be a 0. I caught myself. So I get a 0 on the left. And an x squared minus 8x on the right. We're going to solve this by graphing. X squared y equals x squared minus 8x graph. Where does it hit the x-axis? I'm going to zoom 6. It hits at 0 and 1, 2, 3, 4, 5, 6, 7, 8. 0 and 8. Again, we can check that here. The y's are 0 at 0 and 8. So my two solutions are 0 and 8. And you have to check them both. You have to check them both. Sometimes they will both work. Sometimes neither one works. And sometimes just one of them will work. So go back to the original. 8 times 0 is equal to 0. And the square root of 8 times 8 is supposed to be equal to 8. And they will both work. 0 and 8 are your two solutions. We can put that in set notation. All right, we're going to jump down to number 15. The square root of 6m minus 38 is equal to m minus 5. The radical here is already isolated. We're just going to go ahead and square both sides. The left side just becomes 6m minus 38. Now, the right side is tricky. We've already talked about this in one of our other lessons. When you have something like m minus 5 squared, it means m minus 5 times m minus 5. And what you have to do is go to the side and do all of this multiplication and combining of like terms in order to get what that's equal to. These two are going to combine. So m minus 5 squared becomes m squared minus 10m plus 25. Again, this is a quadratic because of the m squared. We're going to get everything on one side and a 0 on the other. I'm going to subtract 6m. Negative 10m minus 6m is negative 16. I'm going to add this 38 to the 25. And get 0 equals m squared minus 16m. 25 plus 38 is going to be a positive 63. So then we need to plug that into our y equal. We can't use the m though. Just use your x squared minus 16x plus 63. I forgot the x. And then we're going to graph. It hits the x-axis at 7 and 9. So 7 and 9, sure enough, there's the zeros at the 7 and the 9. So are 7 and 9 both going to work is the question. And for time's sake, I'm just going to tell you that yes, they both work. Okay? Both 7 and 9 work. Again, please understand that there are going to be times when one of those may not work and sometimes when neither one works. But for time's sake, I'm going to cut this video here. This is your notes for lesson number 3. solving radical equations.